We are today going to learn Pandas. Pandas is a Python library that is used mainly for data analysis, data science, and machine learning tasks. So if we are going to use Python for any of the data related activities, we must know Pandas. Pandas is built on top of NumPy, which is another library that you can use to perform any of the data related activities. So today we are going to learn some basic commands in Pandas, how we can use Pandas to view our data, to perform some basic data manipulations, to analyze the data, and so on. So let's get started. I'm going to be writing my script in Jupyter Notebook, and if you need help with installing either Python or Jupyter Notebook, then there's a link above and in the description box below that you can check out and install these softwares. They're freely available, so they are very easy to install. So the first step in any Python script when you're going to use a particular library is to import that libraries. So I'm going to import Pandas. And I'm going to give it an alias so it is easy for me to refer to any of the Pandas function later on in my script. So I'm going to call it as PD. So once I've imported Pandas, the next step for me is to read some data. So before starting with any of the other functions of Pandas, we should be aware of two basic data structures in Python or Pandas, which are going to be a series and a data frame. Now a series is a one-dimensional structure, so it is just a list of values. So the way you can define it is you can say S is equal to PD dot series, and within square brackets, within round brackets, you have to provide your square brackets and provide the values for your series. Now you can execute this, and to display the values, you can just do a print S, which is the reference that we have created for the series over here. And when you do a print, it is going to print the values of your series, as you can see over here, as distinct rows. And it is also going to tell you the data type, which is integer 64, because all our values inside are integer values. Now you can also have a mix of values in your series. So we can say PD dot series, and within round brackets, another pair of square brackets and a value. So we can say 1, and we can say A, and we can give some alphabetic values and so on. And now if I am going to print the values of this particular series, I will get my values. And I will get the data type as object. So object is a data type when you have alphanumeric kind of values in your series. So this is one kind of data structure. It is a one-dimensional array because you just have the values. Now, if you want to have a two-dimensional array, which is something equivalent to a table in a database, then you have to go for something called as a data frame. A data frame is a two-dimensional array where you can define your columns, you can define your rows and your columns. Now I'm going to give some values to a data frame. So I'm just going to mark my indicator as df is equal to, and this is going to be a data frame. The similar format PD, but here you have to say data frame, and within round brackets you have to make square brackets and give your values. So I'm going to pass the same kind of values, 1, and let's say A, 2, and so on. So only 3 values. Let's pass the 3 values, and now let's print a data frame. So we are going to say print df, and you can see the values are generated over here. Now, if you take a look over the values generated for a series and the value generated for a data frame, you will see if you look at these first values, so 0, 1, 2, 3, and so on, these are the index values generated by Python. So if you look here for a data frame, the index values generated for each row. There's also an index value generated for the column, because this is a two-dimensional array. So it is something called a table, because we have not provided explicit column names. Now, whenever we have tabular data, we have some column names associated with it. So if you want to create a data frame with explicit column names, then you can also do that. And the way to do that is you have to define your column names in this format. So you can say PD dot data frame, and then within around brackets, you have to provide curly brackets. You have to provide the first column name. So let's say my column name is going to be department ID. Then you have to say a colon, and within square brackets you have to provide the values. So let's say 1, 2, and then for the next column name you have to separate it with a comma and get the column name. So let's say it is going to be department name, and the values will be provided within square brackets and separated by the column name with a colon. So the values in this case, you can say maybe HR, and then you can say maybe sales. So if your alphanumeric values are there, you have to provide them within quotes. So this becomes your data frame, and these are going to be your column names. So we are going to execute this, and then we are going to print this data frame. So print df1 is going to give us these column names. So you can see the column names have been created as department ID and department name, and here are your indexes created for these simple rows. When you're working in real lifetime scenarios, then in most cases you will be dealing with data that comes from external sources. So the data might be in the form of a CSV file, a text file, or it might be coming from a database source, and so on. So now we are going to see how we can read data from a CSV file. So to do that, we can use, let's define a data frame, and we can use pd.read_CSV, and then within this you have to define the location of your file. So I have a file over here. I'm just going to copy this location. So I have a file called employees over here, and go back to my program, and within double quotes I'm going to paste this location. And let's see if this command will work. So you will see that there is an error called the Unicode error. So Unicode escape codec can't decode bytes and whatever. So Unicode error comes. So to take away, to deal with the Unicode error, what you need to do, that you need to put an R over here. And now let's run this command again. Okay, and we get an error again, and this is because we missed specifying the file name. We have only copied the path. You have to specify the file name. So the file name for us is employees.csv. So I'm going to mention that and run this command again, and it should go smoothly. So now what we're going to do is we are going to view the contents of this data frame that we just created. So I'm just going to say a print df2 and run it. So when you do a print df2, you can see that all the contents of the file are displayed over here. So this is the file in the CSV format that we had created, and you can see that the values have been displayed over here. And you can also see that for the manager ID column, they by default has made it as a decimal column. There is something called an NaN that corresponds to the null value in a CSV file. So that is treated as an NaN value or NaN value in Python. So now we are able to access and view the contents of the file. So we are able to read the data from a CSV file. Now we are going to start analyzing this data by running some basic commands. Now when you're analyzing data and the data is huge, you might just want to look at some of the sample records in your data to get an idea about how is the data stored in the source. So to do that, we can run a simple command called df2.head. And this is going to give you a first few sample records of your data. So here you can just analyze. So you can see it has given you 5 records from your data, and you can just have a look at the data and try to analyze it. Now the second command that can be used very helpfully for any analysis purpose is to know what is the volume of your data. So how your data looks like in terms of how many columns are there in your data, how many rows are there in your data. So to find that out, you can run, and it is going to tell you how many rows are there in your data. So 10 rows are there and 6 columns are there in your data. Now you might also just want to find out the count of records in your data. So you can say df2.count, and this is going to give you the count for all the columns. So it has given you the count for every column, and you can see that for all the other columns the count is 10, but for the manager ID column the count is 9 because there is a null value in the manager ID column. So what it has counted is only the not null values. Now another useful command can be df2.info, and here you can see the information about whether it is not null. and what is the count, you can see over here, and what is the data type. We can also do just a df2.columns, and it is going to give you all the column names, and the combined data type is an object of all the columns. So you might also need to sometimes only select specific columns in your data, so that can be done as well. So you can simply say print df2 and within square brackets define your column. So let's say we just want to see the full name. So if we do this, we are just going to get the full name column, the values in the full name columns displayed over here. Now another very useful command is the describe. So you can say df2.describe, and for every column it is going to calculate count, mean, standard deviation, minimum, 25%, 50%, 75% quartile, and max. So if you just want to have information like this for your analysis, this is going to be very helpful. If you want to analyze only a single column, so you can also do that. You have to say df2 and your column name. So column name, let's say we just want to analyze the salary column, and then say a dot and describe. So this is going to describe only your salary column. Now you might have a requirement to sort your data, so that can also be done. So there are two kinds of sorting that can be done. You can sort by the index, or you can sort by a specific column value. So your indexes are the ones that you see over here, which are created by Python. To sort by index, we just have to say df2.sort_index. And to sort by a particular value, you can say df2.sort_values by equal to, let's say, full name. And now your values have been sorted by the column, the values in the column full name. You can also filter your values. So for filtering, you have to say something like this, df2. And within square brackets, whatever is the column you want to filter on. So again, you have to reference to that data frame. You have to say df2 and one more pair of square brackets, and within double quotes, you have to specify the column name on which you want to filter. So let's say I want to filter on department ID, and then come out here and specify your filtering condition. So you want it to be greater than 2. So, and close your square bracket, the second square bracket, and now execute this. And now execute this, and you will get only those records for which the department ID is greater than 2. You can also filter by multiple conditions. So to do that, what we will do, again, we'll follow the same format. So df2 and the first condition, put it within round brackets. So the first condition is going to be df2 and the column name. So let's have the same condition, department ID is greater than 2. And now let's another condition that says salary is greater than 50,000. So to add another condition, you have to put the end over here like this and open another pair of round brackets and put your condition. So df2, and we are going to say df2, and which column are we referencing to this time is the salary. So salary is greater than 50,000. And now if you execute this, you're going to get that single record for which both the conditions are satisfied. So you can also have your other aggregation functions which can be applied for analysis. So you can have df2, let's say we want a sum of salary. So we just want this to be done on the salary column. Dot sum. So you will have the sum for only the salary column. You can have your minimum and maximum. So you can just copy these, and you can have the minimum of the salary and execute this. You will get the minimum. You can also have the max salary, and you can get the max salary. You can also check for null values in your data. So if you simply do a df2 is null, it's going to tell you where there's a null value, for which record you have a null value. So if you look at this table that it has created for 6th row, it is saying that there's a null value in the manager ID column. Now for all these null values, you might decide to fill the null values by a default value. So maybe you decide to fill these null values with a 0, or you might decide to drop all these records which have any null values for your analysis. So this can be done as well. Like if you want to, let's say, drop, or let's say you want to convert the null values to a 0 value. So what you can do is you can say df2 dot fill NA, and you can define your value. So this is going to be a 0 value. And now if you do print df3, because we stored the result in another data frame df3, you're going to get a 0 value where you had the null value. Now you might also decide to drop the null value. So to do that, what you can do is you can say in another data frame, let's contain the results of df2 dot drop NA. And now if you print your df4, you're not going to get that record, so that record has been dropped. Now every time we view the data frame data, we see that an index has been generated. So you can also view the data by your index. You can say df2 dot loc, and within brackets you can say, if you just say 0 and run it, you get only the first record. You can also say df2 dot loc, and within brackets you can say 1:3, and if you run this, you're going to get 3 records identified by the index numbers of 1, 2, 3. So you can see 1, 2, 3 are here, starting from Adams Jennifer till Julia Ford, and that is the data that we have got over here. So it has not considered the first row, which is the actual first record in our output, because it has given it a 0 index value. Now there's another similar function called ilog, so you can use it for a similar purpose. Let's say we just want values 1 and 4th index position values, and run it. So what it has done, it has gone to your first row and it has accessed the 4th column based on the index. So first row, let's say what is the output, it has given us 25/10/2017. So this is what it has picked up, and you can see this is the first index value. It has gone to this row and it has picked up the 4th, so which is actually the 5th column, because the index starts from 1. So the column index for employee ID is 0, full name is 1, department ID is 2, salary is 3, hire date is 4. So it has picked up this value. So you can pick up a value by its index position of its row and column as well. So these two functions have some differences and different interpretations, so that we will discuss in another video. But for now, you should know that you should be able to select data by the index locations as well. Now we can also join data from 2 different sources, and we can use the merge statement for that. So we are going to perform a simple left join. So we have the employees data in the df2 data frame. We also created some data above for the department. So let's use that data. So it is in df1. So df2 and df1, these are the 2 data frames that we are going to join on the department ID column. So what we can do is simply, let's say df5 is equal to ed dot merge, and which 2 data frames are you going to merge? So we are going to merge df2 and df1. Now the next argument is on which column are you going to merge them. So you have to say on equal to and the column name. So the column name, the common column name between the 2 data frames is department ID. So that is what we are going to merge them on. And how are you going to merge it? So are you going to have a left join, inner join, right join, full join, or whatever? So we are going to perform a left join in this case. So that is what we are going to specify, a left join. And if we execute this query and print a data frame with the results, you can view the merged data. So you can see here that wherever the department ID was 1, your department name has been merged as HR. So that is the right department name that we created for 1. For 2, your Department name is sales. We did not create an entry for department ID 3, so it is NAN, which is equivalent to null value, and so on. So you have your department name merged. So this is how you perform. This is equivalent to a left join in a database. This is how you can perform in Pandas using the merge command. And we will see more examples of joins again in a later video. So these are the basic commands that you should know, and these should be enough to get you started with Pandas. I hope that you found the video useful. We are going to be making more videos which will help you understand all these concepts in more details, like merging and like the location indexes and reading CSVs in using different commands and different options as well. So keep watching the videos, and thank you. If you have any suggestions, please put them down in the comments below. Thanks again for watching the video. Goodbye.